All right, so let's start vocabulary. A relation. A relation is a set of ordered pairs they're usually surrounded by brackets, which are different than parentheses, just so you know. They're these things. Mine aren't great. Don't spend too much time trying to make the perfect bracket. It's not worth it. Sometimes I make good ones, other times they're terrible. They belong together. They represent something. They belong together. It's a set of ordered pairs that belongs together. They have some type of relationship. Maybe it's like shoe size and age. Maybe it's number of brothers and number of guinea pigs. I don't know. But they're in this relationship. So, here's some examples, some ways that you could write them. The first way you could write it is a set of ordered pairs. Ooh, look, that one was pretty good. And 1, 5. There's my first ordered pair, and it's inside this bracket, so I know it's a relation. 2, 3 is my next ordered pair. These two ordered pairs belong to something. They have some type of a relationship. I don't know what it is right now, but they've got some type of relationship. 4, 2. And let's do another one. 3, 2. Not too shabby on those brackets. This is a relation. If I said, hey guys, here's a relation, you'd be like, oh, okay. It's a set of ordered pairs that belongs together. How do I know they belong together? They're inside the squiggly doos, the brackets. And if I said, hey, could you take this relation, set of ordered pairs, and put it into a table? And you'd be like, yeah, I think I could, Mrs. Long. So we could put it into a table where our x value and our y value. Now the trick is the x value needs to be in order. So, looking at these ordered pairs, what's my first x value? 1. 1, 5. What's my second x value? 2, 3, right? The ordered pair is 2, 3. 2 is my second x value. Then what should I put? 3, 2. And last but not least, my x value needs to be in order when you put a relation into a table. You could also put a relation. I could say, could you graph this? But let's not spend our, hopefully I don't have to spend my time showing you how to graph it, right? But if I did this, right? I'm not going to make it a beautiful graph. But 1, 1, 2, 3, 4, 5. I'm not spending a whole lot of time on this graph. 2, 3, 4, 2, 3, 2. Yes? We feel comfortable with graphing? I don't have to over-explain what a graph looks like? Okay. So you could take a relation and you could put a relation into a table. You could put a relation into a graph. Here's the one that is bizarre. You could put it into a mapping diagram. This thing is new. Hopefully you've seen a table before. Hopefully you've seen a graph before. Mapping diagram is the new thing. To make a mapping diagram, both X and Y are in order. Then you draw arrows to connect the pairs. In a mapping diagram, a relation can be put into a table, a relation can be put into a graph, a relation can be put into a mapping diagram. Mapping diagram is new. Mapping diagram is the new thing. All the cool kids are doing it. But in order to make a mapping diagram, you have to put both the X and the Y values in order, and you draw the arrows. So if I look, my X values are in order right here. Do you agree? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And I have to put my Y values in order. So I have 2, 2, 3, 5. I'm also not going to write any repeats down. It's just 2, 3, 5. And then I'm going to draw my arrows. 1 goes to 5. 2 goes to 3. 3 goes to 2. And 4 goes to 2. It's a mapping diagram. You'll see it on the 8th grade state assessment. But it's a relation. A table, a graph, maybe a mapping diagram, or a set of ordered pairs. A relation is a set of ordered pairs, a set of numbers that belongs together. Relation. Well, I know that it's a relation. I know that they have some type of relationship because they've got the brackets that group them together. Then we've got some more vocabulary. This vocabulary word is called a domain. Inside a relation, inside a group of ordered pairs that have a relationship to each other, there's a domain. And domain is the fancy word for the X values. Inside a relation, if I said, hey, here's this relation, here are these ordered pairs that belong together, and then I said, can you tell me the domain? You just list the X values. Domain, fancy word for X values. We need to remember that they are in order. Least to greatest. Smallest to largest. Domain. Domain are just the X values. List it out. Don't repeat. If your X values are 1, 2, 3, 4, you'd write 1, 2, 3, 4. Those are the X values. None of them repeated. I just listed them out. Domain, vocabulary word. Relation, vocabulary word. Domain. Range, Domain is the x values. Range is the y values. So range has two definitions in mathematics and algebra. Range are your y values. In order. Don't repeat. So in that example relation that we did up top, if I said, here's a relation, it's written there in purple, you'd be like, yes, Mrs. Long, that is a relation, because it's ordered pairs and they're in brackets. If I said, hey guys, in this relation right here, can you tell me the domains? You'd say the x values in order. If I said, can you tell me the range? Can you tell me the ranges of that relation? Yeah, you'd say 2, 3, 5. I have to say it in order and I don't repeat. Last vocabulary word today is function. So we had domain, range, we had relation. Now we're going to talk function. A function is a relation, set of ordered pairs. Or maybe it's a table, or maybe it's a graph, or maybe it's a mapping diagram, right? There are 4 ways to show these. It's a relation where all domains, a function is a relation, set of ordered pairs, where all domains, what are the domains? X values are different. The x values do not repeat. There's a more mathematical definition, like if you Googled definition of a function, it would not say a relation where all domains are different. It would say probably something like, for each domain, there is one unique range or something like that. But what that means is that your x values, or each range, each value has its own unique, right? Like it just means that your x values are all different. There are no repeating x values. Your x values cannot happen more than once. Each x value is different. Your y values, we don't care. They can be all the same. They can go 1, 2, 1, 2, 1, pattern back and forth. Let's try it out. Answer some questions. I'm going to give you a relation. I would like you to take this relation and tell me the domain, the range, and is it a function? Here's a relation. Remember the domains defined up top. Range defined up top. And then a function. For each domain or x value, there is one unique our x values do not repeat. The key is, the part that we forget the most, is that when you are doing your domains, you have to put them in order. 3, 4, 5. It's hard. My range, -2, -1, 0, and 1. When I put them in order, -2, -1, 0, 1. And is it a function? Is each domain different? No. X equals 3 repeats. Now sometimes this relation, right? A set of ordered pairs surrounded by brackets. Sometimes they'll give you a table and they'll say, can you write this table as ordered pairs? So you have to go back and forth, right? Sometimes they'll say, take this graph, and can you take this graph and write it as a table? Sometimes they'll give you a mapping diagram and say, hey, can you take this mapping diagram and write it as a set of ordered pairs? Right? It's going to be all kind of interchangeable. It's just a set of ordered pairs that belong together, values that have a meaning. Well, there's one more thing about functions, and sometimes they give you graphs, and I'm going to have to really zoom in on this, but sometimes they give you graphs that aren't made up of ordered pairs. What kind of graph would these be? What did we learn about yesterday? They'd be continuous, right? So we have this other idea of continuous graphs. So it says, we use this vertical line test. Which direction is vertical? Perfect. To determine if a graph is a function. So instead of listing out all of the numbers, which would be a huge pain because this is continuous, so there are really, infinite answers, right? We use this idea of the vertical line test. Remember that a function is when no x values repeat. No x values repeat. So when the data is in a relation or a table or a mapping diagram, it's easy to look and say, yes, it's a function. Because all of my values are easy to identify. But over here, it's a little bit more difficult. Do you want to write down every single ordered pair in here? I don't. So we use the vertical line test instead, and that means that we run the vertical line, your pencil, over each graph. Make sure you're vertical. Don't be diagonal. Don't be horizontal. It's called the vertical line test. Are you ready to see what this looks like? All right, so yes, it is a function. The answer is yes. If your vertical line touches 1 point at a time. It is a function if your vertical line touches 1 point at a time. It is not a function if it touches more than 1 point It is a vertical line or it is a function if your vertical line touches 1 point at a time. It is not a function if your vertical line touches more than 1 point. All right, so here we go. Sometimes these are hard to see, so I'm going to go over it in pink just so you can really see what we're looking for. All right, here's my vertical line. And right here, I'm touching 1 point of that graph, correct? 1 point, so I'm okay. But when I move to the next tick mark, what happens? I'm touching 2 spots. 2 spots. It is not a function. In this second one, there's my line. And if I go over, I'm okay right now. I'm okay right now. I'm okay. And I keep going, and I only touch 1 spot at a time. So yes or no? Yes. Function. Then number 3, it's right here. And if I go vertically across, right here, I'm touching 2 spots. You guys, these ordered pairs that I'm touching at the same time, this ordered pair is 1, 1, and this ordered pair is 1, -2. The reason this is not a function, your x value repeats. So it cannot be a function because our x values happen more than once. The y values are different, but I don't care about the y values. I cannot have the same x value, not a function. Number 4 is right here. And you have to get pretty close. I would say right there it's touching 2 spots at once. Do you agree? Not a function. Because the x value repeats. Here, I'm touching 1 at a time. Function or not a function? Yes, function. Ooh, this right here, when we get into quadratics at the end of the year, this is called a parabola. Tell me, yes or no? Yep, it's a function. What about this guy? Nope, because I have 2 dots vertical to each other, right? It touches my vertical line twice, so no, not a function. What about this one? And what about this guy? Nope. Vocabulary heavy day. Yes?